Welcome to the final tutorial in the Astrolabe mass cytometry platform series. Here, I will give you a brief survey of the various experiment exports that are available through the platform. The exports allow you to easily get analysis results out of the app and interact with them locally on your computer using any other piece of software. The usual disclaimer applies. 1. If you haven't already, I strongly suggest that you watch the previous videos in this series. 2. We are improving the platform on a regular basis, so the current interface might be slightly different than the one I'm presenting here. The data for this experiment comes from Tordesillas et al., a paper from the Cecilia Baron group that was published in 2016. In this paper, samples from peanut allergic patients were compared to healthy controls using an immune monitoring approach that relied on mass cytometry. When logging into Astrolabe, I enter the experiments page, which lists all of the previous experiments I uploaded to the platform. From this list, I can choose Tordesillas et al. The experiment exports are available through these three buttons at the top right of the page. Astrolabe offers three types of exports: gated FCS files, reports, and R files, all of which are downloaded as compressed zip files. First, the gated FCS files export includes the FCS files that I uploaded during experiment setup, split by the subsets found by Astrolabe. Within the zip file, samples are organized into subdirectory. In each sample subdirectory, I find a set of FCS files, one for each of the subsets identified by the platform: various B cells, basophils, various T cells, and so on. These subsets correspond to the profiling level as described in the Immunophenotyping Navigator tutorial. Therefore, they cover both the manually curated hierarchy and the following data-driven separation. In addition to cell subsets, this directory has the bead and debris files, which include events that Astrolabe removed from its analysis. The next export is the reports directory, which includes static versions of all of the figures I could generate through the platform. Within the samples directory, I again find a subdirectory for each sample. There, I can find cell count plots for each of the cell subset levels. So in this bar plot, the x-axis is the cell subsets, the y-axis is the number of cells. The cell assignments heat map. Here, the x-axis is the channels, the y-axis is the subsets, and tile values correspond to channel intensities. And the gating strategy for removing beads in this file. Here we see that the beads are high for CE140 and EU151. These are the events that were removed by the platform. I am going to return to the cell assignments directory for this sample. Every figure is accompanied by a CSV file that includes the raw data for that figure. Here we see the cell subsets, the channels, and the normalized intensity for each combination. The data is always available at your fingertips. Leaving the samples directory, there are two experiment directories. The first, experiment cell counts, includes the heat map for cell counts across all samples. The x-axis is the subset, the y-axis is the sample, and the bar plots for each cell subset, the frequency of B cells in each of the samples. As before, each file is accompanied by a CSV that includes the raw data required to generate it. Figures and CSV files are available for both the assignment and profiling levels. Finally, the differential abundance analysis includes all of the statistics from the test. for each of the cell subset levels and each of the features defined during experiment setup. You can find the statistic results, fold changes, p-values, FDR values, and medians. You can find a labeled volcano plot, the bar plots, color-coded by the feature values, and in addition, box plots that show aggregate statistics for this cell subset. The last export is the R files or analysis export. This zip file contains a large number of RDS files. These files are used by the R programming language and cover all of the analyses, including intermediate steps that have been done by Astrolabe. We released an R package named orloj, which allows our users to easily interact with this data. You can load an experiment with one line of code. You can load a sample with one line of code. You can browse around channel intensities on the single cell level. You can examine the results of the assignment and the profiling cell subsets. You can get aggregate statistics. These show you the number of cells in each subset, and these show you the channel intensities for each subset. Finally, you can get experiment-wide statistics, including the results of the differential abundance analysis, p-values, fold changes, and so on. You can find the link to the orloj package in the description of this video. One of the major goals behind the Astrolabe platform is transparency. As one of our valued users, we want you to feel confident in the analyses we provide and know that you can always get back to your data and your results. You have complete access. In this tutorial, I examined the 3 exports that help us achieve this goal: the gated FCS files, reports, and R files. This concludes the mass cytometry tutorial series. I have shown you how to set up a new experiment, validate and explore the cell subsets using Immunophenotyping Navigator, draw experiment-wide insights using the cell subset navigator, and get full access to the analysis results using the experiment exports. You are welcome to contact us if you have any questions, concerns, or feedback regarding the platform. Thank you for your time and enjoy analyzing your data using the Astrolabe platform.